In this lesson, we'll discuss learning target number 5, performing stoichiometry calculations involving solutions. Now that we know the equation C equals N over V, and we have a way to relate the moles of a solute in the concentration of a solution, we can add another link onto our mole map. Here, if we have the concentration of a solution, if we times it by the volume in liters, we'll get the moles of the chemical. This is our stoich mole map. We can now start at the concentration of one chemical and go to the concentration of another chemical. Nothing's new in terms of the stoichiometry. All we have is one more place to start a question or finish a question. We can still do limiting reactant questions as well as percent yield calculations. Let's do some examples. I'm going to start example 1 by writing the balanced chemical equation. Here we're reacting mercury 2 nitrate and sodium chloride. I'm going to spread it across my page so I can make an organizing chart underneath. This looks like it might be a double displacement, and when I check my solubility table, HgCl2 is a solid. So this is going to be a DDP. I'm just going to record the numbers that are given in the question underneath the corresponding chemical. That keeps me nice and organized. You notice I have the concentration and the volume of my mercury 2 nitrate. And I'm given the concentration of my sodium chloride solution. The question asks me what volume of NaCl do you need to completely react so that there's no extra reactants. So I'm trying to figure out what volume do I need to mix these reactants in their stoich ratios. Because I have complete information about my mercury nitrate solution, the concentration and the volume, I can determine how many moles of mercury nitrate there are using C equals N over V. If I rearrange that, the moles will equal the concentration times the volume in liters. Now to convert that into sodium chloride, I better balance my chemical equation. I forgot to do that. I'm going to need a 2 here and a 2 here, and then now I'm balanced. So I'm ready to convert from one chemical to another. I'm going to times by what I want, NaCl, and divide by what I have, mercury 2 nitrate. Now, in order to find the volume of sodium chloride solution I need, again, because it's a solution, I'm going to use the equation C equals N over V. I have the C, that's 0.0512 mole per liter, and I have the moles, 0.0125. So then I just rearrange this equation and find V. My calculator's telling me that V equals 0.24414. Now that would be in liters. If I take my sig digs into consideration, I can only report 3 numbers. Each of the numbers in the original question had 3 sig digs. Or if I want, I can times this by 1,000 and convert it into mils. So 244 milliliters. Now example 2 forces us to find the limiting reactant. Again, there's no difference from what we were doing in Unit 3, except that we're going to start with volumes and concentrations of solutions. Now in questions, we don't always need to start with concentration and volume information. We could still start with the grams of a solid or the amount of particles. In this question, we're asked what the mass of the precipitate will be when we do a double displacement together, mixing sodium hydroxide and magnesium iodide. Let's start by writing the balanced chemical equation. In this double displacement, my sodium is going to go with the iodine and my magnesium is going to go with the hydroxide. Put my states in. In this case, the magnesium hydroxide is insoluble on my solubility table, so it's going to be my precipitate. And I'm just going to organize my numbers here. I do this because it's really easy to switch a number. And I almost forgot again, I have to balance my equation. There we go. Now we're ready to start our question. I need to figure out which is the limiting reactant. And it's pretty hard to do by looking at these numbers. Remember, you can only compare the amounts of chemicals in moles. Here I have different volumes and different concentrations, so I can't compare these two. So my first step is to change the reactants both into moles, but then convert them into the same chemical. Remember, that gives me both of my values in the exact same unit, moles of the same chemical. So let's start with the magnesium iodide first. Because this is a solution, I'm going to use C equals N over V, and I'm going to rearrange for N. It's going to be the concentration times the volume in liters. While I have that in my calculator, I might as well convert that over into magnesium hydroxide. I have a 1 over 1 mole ratio. Now let's go back and do the sodium hydroxide. Same process. I take the concentration of the solution and times it by the volume, convert it into liters. That'll give me moles. And then I'm going to convert this over into my magnesium hydroxide, and here I'm going to have a 1 over 2 mole ratio. Now I can directly compare these two numbers. They're both in moles of magnesium hydroxide. And you notice this one's smaller, so that makes my sodium hydroxide my limiting reactant. Now I'm going to answer the question with this number here. I have the moles of magnesium hydroxide. The question asked me to express that in grams. I'm going to use the m equals n times big M equation from Unit 3 in order to do that. the molar mass of magnesium hydroxide works out to 58.33 grams per mole. That's what my calculator tells me. And then I need to worry about my sig digs. Remember, I had to use my limiting reactant number. That came from sodium hydroxide, so I need to take my sig digs from these numbers. They both have 2. So I'm going to round this to 0.77 grams. Try out the solution stoichiometry questions on your assignment cover sheet for homework.